Our project was using content card analysis to maximize user engagement for the DraftKings Sportsbook application. A content card is a pre-made widget that DraftKings offers on their Sportsbook application that presents pre-made parlay bets to users to enhance the user experience by not requiring a user to construct a parlay bet on their own. Our problem was, given a set of these content cards that are arranged in a carousel, where should a new card be placed in order to maximize user engagement? And we measured user engagement by bets per minute. For example, if we had 2 cards in the current set and we were adding a third card, there are 3 different positions that card could be inserted into. And we used a local search algorithm in order to determine which position would lead to the highest increase in change in engagement. In this example, if we placed the card in the first position, we might get 2.6 bets per minute more than we had before. If we place it in the second position, we might get 1.4 bets per minute more. And if we place it in the last position, we might get 0.2 bets per minute more. So in this case, putting it in the first position would be the optimal position. To do this, we were given a historical data set related to content cards and user engagement measured by bets. For example, we were given the title of a card, we were given the subtitle, the different legs that were present on the card, the number of legs, the type of bet, which is either a parlay, a same-game parlay, where all the legs of the parlay bet come from the same game, a SGPX, which is a same-game parlay, except there's one additional leg coming from a separate game, and a single, which is just a single bet. The carousels are broken out by zone. A zone can be a different league or a different sport. This example here, there's the MLB, the NBA, and the Celtics. We focused on the NBA, the MLB, and the NFL zones as they had the highest number of samples and the highest magnitude of engagement. The odds of the card were also present. The odds were a dynamic feature. They change throughout the day as lines move, as certain users bet more on certain bets. So we had the odds at the time of each bet being placed. We wanted to get this down to a single feature to use for our models, so we tried the maximum, the minimum, the median, and the average, and we ended up choosing the median odds to use for our model. Another feature that we wanted was the sentiment analysis of the subtitles. We thought maybe that more positive subtitles may gain more user attraction. So we used an open source natural language processing library to find the positivity, negativity, neutrality, and polarity of the subtitles of the card. We also wanted an idea of the popularity of the players and teams that are present on a card. And with a lack of live performance metrics, we decided to use an implicit measure where we would use a name entity recognition model to extract the proper nouns from a card. So this would extract the players and the teams. We would then look in the 4 weeks prior to a card and find the engagement of cards containing that player or team. And then at the end, we would take a card, we'd find all the proper nouns on that card, and we'd find the most popular player, the least popular player, and the average popularity, and use those as features for our models.
To give you an idea of how the carousels work every day, so each day a new carousel is created of cards, and this process is all iteratively, so DraftKings doesn't just put 9 different parlay bets onto the software at once. They add them as they create them. So say at 2 p.m., they add their first card, and then 30 minutes later they add their second card, and then so on. And then throughout the day they start to remove the cards as the games begin. But we decided to look at the additions, not the deletions of cards, and trying to predict, given a new card, should it go in that first position or second position based on what our model thinks will increase the most bets per minute.
Yeah, and so we considered for our project 2 different data splits. First, we utilized a sequential split where we trained on the months, for example, in the NBA heat map to the right, trained on the months from October to January, validated our model in February, and then tested on the remaining 2 months. However, after conducting further research, we found that the distribution distances of the engagement change were pretty different from a month-to-month standpoint. As you can see in February, there is a lot of variance in that month compared to the rest of the months. And so we came to an idea that maybe a sequential split with the data we were provided was impractical given that there's so much deviation, and so we opted for a random split.
Yeah, so once we had our splits determined, we went into our modeling, and to start, we created baseline models for each of the zones. And for our baseline model, it just purely predicted the mean engagement change across all of the training data. This wouldn't be helpful for DraftKings at all, but it gave us an idea of where to start from and how our models could improve. And we measured the root mean squared error as an accuracy metric for our models. Once we had our baseline, we created 3 different types of models: a random forest model, a multilayer perceptron model, and an XGBoost model. And each of these models performed pretty similarly for most of the zones. One thing we noticed in particular was the random split did achieve much better results than the sequential split, which matches what Bobby was just talking about with the monthly distributions. And in each of our cases, we were able to beat the baseline by between 5 to 8% in the NBA and MLB zones, and in the NFL zone, we beat it by 37%. To compare our models to the state of the art, we also used Data Robot on our feature set. Data Robot, what it does is you put the data set in and give it a target variable, and then it runs a ton of models automatically. And Data Robot achieves pretty similar results to what we had, pretty comparable, so that gave us some validation that our models were pretty good.
So for our deliverable to DraftKings, we created a model wrapper. So a user can essentially choose the zone that they want their prediction for, the model that they want to use, and input information about the card, like the title, subtitle, number of legs, the start time, end time, and so on. On the back end, we extract, based on the start time of the card, the carousel that was in that zone at that time. And we also extract the features of the card that we then input into the model. And the model essentially predicts the engagement change for every single position that the card could go into in the carousel, and then it gives the optimal position back to the user.
So after we created this model wrapper, we also wanted to test and see just how it was doing with our data, and if this method would be valuable for DraftKings. So we tested it, and we did an aggregation of all of the different bet per minute engagement increases for each of the positions. And so looking at our model where we would put the card in DraftKings position versus our model with the card in the optimal position, we are able to see a sizable increase in the bets per minute, particularly in the NBA zone. This made a lot of sense to us just because this was the zone that we had the most data for, and so our models were able to train on more data, learn it better, and then test some more data. For the MLB zone, we weren't able to see as much of a sizable increase, nor for the NFL. The NFL, we actually saw worse results than the other 2 zones, and we attribute a lot of these differences to the different sizes of the data sets that we have, because the NFL was significantly smaller than the other 2. So although it did really well when we were training our models, it didn't perform as well when we were testing it with the wrapper.